So important foundationally for discussing redox reactions is what are the oxidation states or numbers of particular compounds. So let's take a couple minutes and talk about the rules for assigning oxidation numbers. So rule number one. You know what, I'm going to try a highlighter this time instead, okay? Rule number one, the oxidation number of an atom in an elemental substance is 0. In other words, if you have hydrogen gas, the oxidation state is 0. If you have nitrogen gas, the oxidation state is 0, right? You can see that, right? If you have sodium metal, right? Let's say sodium solid, the oxidation state is 0 because these are in their elemental state, okay? So it's going to be 0. Now, the oxidation number of a monatomic ion is equal to the ion's charge. Monatomic ion is equal to the ion's charge. So if I have sodium, its oxidation state is +1. If I have chloride, I'm getting faster, we'll change my markers, aren't I? Its oxidation state is going to be -1. If I have oxide, look at me blazing, O2 minus, its oxidation state is going to be -2. Right, so the oxidation state of a monatomic ion is equal to the ion's charge if it's monatomic. Rule number 3 is the oxidation numbers for common nonmetals are usually assigned as follows. Hydrogen is almost always +1. However, sometimes it's combined with metals, in which case it's -1. So hydrogen is usually +1. Sometimes it's -1. This is like a good solid rule, okay? Almost as solid is oxygen. Oxygen is -2 in most compounds. -2 in most compounds. Sometimes it's -1. In other words, if it's with hydrogen in a weird way so that it can't be -2, then it might be -1, okay? And rarely it's -1/2. So really we could probably cross that off. Don't worry about that. And it has positive values when it's combined with fluorine, which we rarely see. You know what you want to do? You want to memorize really that oxygen is usually -2. It's rarely -1 and even more rarely these other things. So hydrogen is usually +1. Oxygen is usually -2. Halogens are usually -1, right? For fluorine, it's always -1 when it's in a compound. And for the other halogens, it's -1, if it can be, right? We'll practice this in great detail. Okay, rule number 4 then is that, let's go back to our highlighter, the sum of the oxidation numbers is equal to the charge of the molecular ion. So if something's neutral, the sum of the oxidation numbers is going to be 0. If it has a charge, it's whatever that charge is, right? So let's do a couple examples. Let's start out with H2S. Well, remember, with H2S, let's go back up to rule number 3. Hydrogen is usually +1 when it's with nonmetals. Well, sulfur is a nonmetal, and so we're going to say this is +1. Well, you see that the rule number 4 was that the sum of all the oxidation states is going to have to equal 0. So watch this. +1 times 2 gives you +2. Plus something gives 0, right? Because there's no charge here, right? So what +2 gives you 0? Well, -2. So this sulfur must be -2. Okay? And can you see how the sum of all these oxidation states then gives you the charge? Right, there's my charge right there, which is 0. Okay, let's do another one. Let's do black SO3 2-. I'm always going to do my little math on the bottom, always on the bottom, right? And so I can see that all the sum of everything is going to have to be -2 because that's what the charge is, right? So oxygen has, let's go back up and look at the rule. Oxygen has a tendency to be -2 unless it's with a peroxide or something else. But look at this. It's usually -2. So let's go back down here to say, and this must be -2. There's 3 of them, so -6 total, right? What -6 gives you -2? Looks like that's going to be +4, right? Well, there's only one sulfur atom, so this must be +4. And that is it. Amazing. All right, let's do one more example, and then we'll go back to the oxidation reduction conversation. So let's do sodium sulfate, and let's do it in black. Keep our colors consistent. Na2SO4. Okay? There's a couple of ways we could approach this, but you know that the sum of everything is going to be 0 because there's no charge on it, right? So oxygen is typically -2, and sulfur, or rather sodium, is typically +1. I guess always +1 if it's in a compound, right? So it looks like there's 2 of those. That's going to be +2. And there's 4 of these, so this is going to be -8. So how do I combine these to get 0? +2 plus what? -8 gives me 0. It looks like it's going to be +6. Agreed? And there's only one sulfur atom here, so sulfur must be +6. All right, +2 plus 6 minus 8 gives me 0, and that is legit. That is the correct answer. So that's the method that we're going to use for assigning oxidation numbers. Again, oxidation number of an atom or an element in its elemental state is going to be 0. Oxidation number of a monatomic ion is equal to the ion's charge. If it's monatomic, this is not monatomic, right? And then rule number 3 is probably the most important, and that is that hydrogen is typically going to be +1, oxygen is going to be -2, and the halogens, where am I here? Halogens are typically going to be -1. And finally, the sum of all the oxidation states, or oxidation numbers, is going to equal the charge on the ion or molecule. All right, let's go practice it.